Hi everyone, so today is day 5. Let's solve this problem. Let me move this coming in between. Hey, today is day 5 and the problem is okay. So it is downloading the data from the Kaggle. So let's first understand. So the step by step plan is going to be we have to load the data first. We are going to load the data from Kaggle. Uh, so which can be labeled as spam and not spam. You can find the dataset like this on Kaggle. You can use something like Enron dataset. Okay, so it says I can get the data from here. Let me see how the data looks. Okay, the data is 404 now. The data is data data at is throwing 404. Can we For start, can we create a list of emails, list of 20 emails, spam and not spam, and use that, and later maybe can use scikit-learn dataset. So until now we have seen that we have been using scikit-learn dataset for almost to solve all of our 4 previous problems. So yes, it says we can. So it has given me a list of 20 emails, and it says randomly it is a spam. It is not a spam. Spam not a spam is ham. Spam is ham. Spam ham. Okay. Now it seems better. Then it has. Let's now go and understand. So we will load the data, our own data. Pre-process the data. In the pre-process, we will tokenize the text and convert the text words to numerical features. Let's understand that. And then what is this naive bias classifier? So naive bias classifier is we are working on filtering spam from a collection of emails using naive bias classifier, which is commonly used algorithm for text classifications. Okay, so it is a famous algorithm to solve text classification type machine learning problems. Okay, again this spam and non-spam is a text type classification problem, so naive bias classifier, which is great for text classification because it works well with the assumption that each feature is independent. Okay, then we will train it and then we will show the prediction using the accuracy store. Later we will also visualize it with the help of the libraries matplot library and see what was the name of that library, I forgot. Seaborn. Okay, so we will create a heat map at the end. Then it says to load the data pre-processing and all. We will dive into that. So let's start writing the code, and whatever things we will stuck at, we will go and understand again from the chat GPT. So let's start. Uh, Let me scroll it, move it a little down. I'm creating a new Python file and it is going to be day5.py and I have added it. So it is going to be I have to import files. I'll import first what import is going to be import pandas as PD, import sklearn as feature extraction dot text, feature extraction dot text. Uh, Actually, not import from this import count vectorizer. So we'll understand what this is later. Then we have to do sklearn dot model selection import. Which model are we in? Achha, model selection test train test split. We will use it to split the data into training and validation sets. Then we have to use import the model from name bias, which is multinomia NB. We will understand how this works later from ChatGPT only. So sklearn dot it is going to be naive bias import multi multinomia NB, and then we will see import accuracy score from matrix. Matrix import accuracy score. That is it. Let's this step one is going to be load the data. First is create the data. So I'll simply go and copy it. I don't think it is a rocket science. It makes sense to me to write everything here to create. Okay. So here every email comes under this message key. For example, this is an email. Win 1,000 Walmart gift card. Click here to claim now, and it says it is a spam. Then I have another email called "Hey, are you coming to the party tonight?" And it is not a spam. It is a ham. So this is the data. Then we will go to the step two. Load the data. So we'll do what? We will create a data frame of p from panda dot data frame. Here we are passing the data, and let's print this data frame. I'll move a little up. I'll run this day 5 file, and I can see the label and the message is this. Let me rename this to email, because the problem is, let me write the problem here. Problem is day 5 problem है. Hang on, I have gap. Problem है filter spam from a collection of emails. So let me change it to emails, and then it should show email. Okay, and it is again a classification type problem, but this time it is a text classification. But this time it is a text classification task. Okay, now let's go and then rerun it and see what this is going to do. I'll not this, so I can see it says email and if they are spam or not. I can do this also to see the head only. So let's say run. So I see top 5 elements of from my data frame which are marked as spam or ham. The column name is emails. Let me change it to singular and rerun it. Yes, this is what I want. Then I'm going to do what does the okay. Okay, now it says convert the spam. So I'll instead of that, I don't need to do that actually. Okay, let me do that. So it says convert all the ham to 0, spam to 1. So pre-processing we are doing convert labels, pre-processing, convert the data in, convert label spam 1, ham 0. Okay, spam ham is 0, spam is 1. So I will do that. How I'll do that? Data label is going to be data df dot map, apply map. Okay, data df label dot map. Of this fields we are going to map ham will be mapped with 0, spam will be mapped with 1. And let's print the again data dot df, the data frame. Let's see what it does. Okay, now we have marked all our label as 1 0. Done. Then we have to do what it says that uh, we have to convert the data into numerical feature using count vectorizer. Let's see what that is. We convert the data into numerical text data and convert the text data into numerical features that machine learning understands using count vectorizer. VCTOR. Yes. Let's understand what this is. So it says these are the emails, right? These are emails. And machine learning algorithm or the computer does not understand these texts. So we have to convert them into a form which machine learning algorithm understands. So they understand numerical matrix form data. So we'll have to convert these texts into a numerical matrix, and we will do that with the help of this count vectorizer. Let's understand how this works and then we will proceed on implementing it. So let's see. Can you explain how works with an example of spam, non-spam email? Okay. A lot of information, but we'll go through, read everything, and make sense out of it. Okay, so let me walk you through count vectorizer works. How count vectorizer works with a simple example. It says count vectorizer converts the text data into a matrix of token, which is called word counts. Okay, we will remember this later. Essentially, it creates a bag of words. It creates a bag of words model where each word is in the text is treated as a feature, and the value of each feature is how often that word appears in the text. So we will basically do what we will split the whole email into individual words, and then we will see how many times that unique word has appeared. For example, let's take two example emails, one spam and one non-spam. Win 1,000. So there is a spam mail which says win 1,000 Walmart gift card. Click here to claim now. And then I have another email called, "Hey, are you coming to the meeting tomorrow?" Okay, and it is not a spam. So how count vectorizer proceeds with these email? First, it will tokenize them. So after tokenization, the count vectorizer will break each email down into individual words. For example, spam emails. This when so this email is broken into tokens using tokenization. Like it was win 1,000 Walmart gift card. Click here to claim now. We can see all of the words in lower case, and the ham email is this. Then we will go to the second step of this count vectorizer. It says that next count vectorizer builds a vocabulary of unique words from all the emails. This vocabulary is like a list of distinct words in your data set. For our two example emails, the vocabulary will look like this. Okay. So what it is doing, it is creating a vocabulary of unique words. For if you say, let me see, can I get anything repeating here? If you see this two is getting repeated here, so if I have included two once in my vocabulary list, I'm not going to include it again. Okay. So two will be added only once in my vocabulary list. So here you can say see that two is added only once. So what it does, vocabulary list is the list of unique words that has appeared in my whole data after tokenization. I mean, whole all the data, all the emails. Once it does that, it goes to the step three, create a count matrix. So it has created a vocabulary list, and after tokenization, now it creates a count matrix. Now, count vectorizer goes through each email and counts how many times each word from the vocabulary appears. The result is a sparse matrix where each row represents an email. Each column corresponds to a word from the vocabulary. The values in the matrix represent how many times the word appeared in the email. For our two example emails, the matrix might look like this. So, what it does is it is creating a count matrix where in the matrix the row represents each email, and then each column represents the words from the vocabulary. So what it does, it will go to each email, the first email. So wherever when is coming, it will increase the count. It says one, that it is coming here. Okay. Yes. And here it sorry, if we let's see, can I see one? Okay. And then the next word is 1,000. So it should say 1A, 1,001 here. Similarly, it will do for the ham. Now the spam email, it is saying the same thing, but let's read it. The spam email has one under the column win, 1,000, Walmart, etc. because those words appeared once in the email. The ham email has one under hey as for the same reason. The word that don't appear in the email has valued as 0. Output of machine learning. The resulting matrix is used as input for the machine learning model. Okay, so this matrix is something that we are going to use later for as input for our machine learning model. Each email is now represented as a row of numbers, and the model learns from these numerical features. Now let's create this matrix, and then we will see how this model uses it later. Okay, so that it makes sense what we are doing it. Hmm. Okay. Okay, let's read it a little. For each email, the matrix of word counts as a set of features. The naive buyers classifier will use the naive buyers classifier. We are using this model. Will use this counts of words. This counts of words like when gift, click to learn which word are more likely to appear in spam emails. Okay, similarly, it will learn that words like meeting tomorrow and here are more likely to appear in a non-spam. So what it does after doing this, it says which words are more likely to appear in a spam email, which words are more likely to appear in a non-spam email. It will do that by getting the probability. We will understand more later once we land and write. We'll be writing code for this model creation. Okay, for example, if we want to see how this matrix should look like, we can see that with the help of this get feature names as in the vocabulary, and then we can get the matrix from by doing two array. So we'll do the same, and later we will understand how this count matrix will be used, which is the bag of words matrix will be used for our naive bias classifier model. Okay, so let's do this. Let's go to the code again and vectorize vectorizer count, and here say stop words are English. We have some spots, so let's understand that. Here, what are what does stop words present? Okay, so it like in normal language, there are words the is in and so don't include those words. It says once done, we'll do what? Come back to our code and we will convert the data into count matrix and store in the variable called x. So we will do what? Vectorizer dot fit transform our data email, and then let's read x. Let's do see what. Okay, I can see something. It says convert the text to a matrix of code. It says convert the uh, text into a bag of words matrix. Okay, and let's do the what. Let's understand it. We saw couple of functions, helpful functions to understand. So we'll do what? We'll do this and see what it will present. Okay, we have created vectorizer. Let's see what this vectorizers. So we have got a list of our vocabulary. This is vec. Let me vec, vocabulary. Okay, this is our vocabulary, and if I want to print the count matrix, it is going to be x2. It was x2 array, right? 2 array. Let's print it. Okay, the 2 array is like that. It makes sense. It makes sense. Right? This is our first row. This is our second row. I mean the last row. So let's comment this. We saw how it has created the vocabulary and count matrix. Let's use it further. Um, let's go back to our code. Now we are going to split the data into training and validation testing sets. So the step 4 is split the data, and we will split into 80-20 ratio. Training will go, training will have 80% and validation data will have 20%. So let's do this. Um, let's do this. Create variables x train, x validation, y train, y validation, and it will go as train test split. X is going to be our x that we have created, as x is going to be the x that we have created, count matrix. Y is going to be uh, the label that we have converted into 1 or 0. So label, and the test validation data size is going to be 0.2, and random, sorry, and it is going to be random set is going to be 2. So I've told you many times that this, we make sure that every time we are running this code we are getting similar split, and we do not get surprise. And 42 is just a random number, uh, no specific logic behind it. And then we'll do what? Train our model. Step 5, train, initialize, create, hang on, create and train model. So we'll do what? We'll create a model using what? If you remember, we have imported a library from our naive bias called a package called multinomial NB. So I'm going to create an instance of that, and it is our model, and we are going to fit the model, train the model on train data against this target. And the next step is, step 6 is uh, make prediction and evaluate. So what we are doing, we are going to do predictions, and predictions is going to be like model dot predicts. We'll predict what? We will predict on x validate, and then we will use accuracy score to get the accuracy. We'll do accuracy score to get the accuracy. So we'll do what? uh, Accuracy score is going to be accuracy of score of the actual values, and it is going to be actually results is going to be the validation and the predictions. And yes, that is it. And then we will print it. It is going to be accuracy score is going to be accuracy score. So let's run it and see how well the model performs. The model says that it is performing accurately. Okay, nice. uh, let's understand how this model is using this count matrix that we have created and stored in the variable called x. So I want to know how the count matrix is used by multi-model. Use the examples same examples as in the example that we have used to make sense out of this count vectorizer, these emails, right? Okay, let's read it. Great question. Let's dive into how the multinomial naive bias classifier works. With the count matrix generated by count vectorizer, we'll break it down step by step using the same spam, non-spam email example. Okay. There was a spam email, this was the spam email, and this was the non-spam email. And the vocabulary it had created was this, we already saw. And the count matrix, this. We saw and understood how it created this count matrix. Now, how it is using it in this multinomial naive Bayes classifier algorithm. So, this algorithm is based on Bayes' theorem, which calculates the probability of an email being spam or non-spam based on the features. In this case, the word counts. The idea in multinomial and naive Bayes is each word is in the vocabulary. For each word in the vocabulary, the classifier calculates the probability of that word. Okay, appearing spam emails and the probability of it appearing in the non-spam emails. If it then uses these probability to decide whether the email is more likely to be a spam or not. Bayes theorem. Okay. So what it does, I have understood, but let's read a little further and then I'll explain you what I've understood. During training, multinomial naive Bayes book looks at the word counts in the email and learns the likelihood of each word occurring in the spam emails and non-spam emails. For example, if the word win appears frequently in spam emails but rarely in non spam emails, the classifier learns that win is a strong indicator of the spam. Okay. The model uses the count matrix. When you pass the count matrix to the naive Bayes model, it looks at each word in the email and calculates the probability that the email belongs to each class. Okay. For each word in the email, that is the vocabulary, it multiplies the probability of that word given spam and the probability of the word given non-ham. The model sums up all the possibility of the words in the email and compares overall probability of the spam and ham classes. Okay, example. This is the email. So what I've understood that it gets the, so there is this. Let's understand this. uh, we have an email and these are the words from the email, and we have a vocabulary list, we have a count matrix. The model calculates how likely it is that this combination of words occur in a spam emails versus non-spam emails. So it will say how what is the probability of a word called win to occur a spam email, and what is the probability of this word win to occur in a non-spam email. And it will do that by using what are count matrix. It, for example, this word win is occurring once in the spam, 0 times in the ham. So the probability of occurring win in a spam email is 1, and occurring in non-spam email ham is 0. It does that for all the words and then combines and then decides on the basis of the combined probability if it is going to be a spam email or non-spam email. Words like win, claim, gift likely have higher probability of appearing in a spam email. Hey, are you coming to the meeting tomorrow? The words are this. The model calculates how likely it is that these words are in non-spam email. Okay. Final. After calculating the total probabilities of both classes, spam and non-spam, the model chooses the class with the higher probability. So, as I've told you, it will calculate the probability of each word, that if it is the probability of this word to occur in a spam to occur in spam emails, the probability of this word to occur in non-spam emails, it will calculate both separately and does for all the words, sum it up, and then the total probability is then used to decide if the whole email is going to be a spam or a ham email. Assume the classifier learned that the following probability based on all the small data. For the word calls win, uh, the probability is 0.1, and the probability of meeting to be in a spam is zero point 0.2, sorry, zero point 0.2 and 0.8. For the word in ham is zero point 0.1. For the word meeting in ham is zero point 0.9. For a new email, win a free iPhone now. Win a free iPhone now. The classifier would see the word win and calculate. So now we'll see we have got the win up free probability now a new email. It will see it has a word win which is there in our vocabulary, and then it will see the probability of win to be a spam and non-spam. Then win to be a spam is zero point 0.8 and non-spam is 0.9. Sorry, non-spam is 0.1. Okay, and does it has any other word? No. So this the probability of yeah a probability of win has a strong association with spam. We see 0.8, 0.1. For a non-spam emails, are you coming to the meeting tomorrow? The word meeting has strong association with non-spam. So it will be it will be treated as non-spam, predicted as non-spam. So this is how it calculates, decides which is a spam, which is not a spam, using the count matrix, and then applying combined probability on them. Yeah, we see that the class spam or ham with the higher probability is chosen as the prediction. So this is what we have understood. We saw our prediction also. Let's I am thinking, let's and what I'm planning on doing is I'm planning on doing to visualize it using the classification. This is a classification type problem, right? And we have been using count matrix. So let's use count matrix. Sorry, we have been using confusion matrix and classification report. So we'll use the same and see, visualize it with the help of graph how it looks. I'm thinking to visualize it with the help of confusion matrix and classification report. Yeah, let's see what it does. Yeah, it says it is a great idea. And I've told you again that confusion matrix is really good. It gives you information like true positive, true negative, false positive, false negative, that we can use to decide further how beneficial or how accurate our model is. Yeah. To know more, you can always go and check and read in detail about the progress posts of my each problem or each day. And there I have in the day 4 I have in detail explained the usage of confusion matrix. So I recommend you to go and read that. So coming back to the thing, I want to visualize it. So I can visualize it with the help of what confusion matrix. So going to create a confusion matrix. For that I have to import confusion matrix, right? So I am importing confusion matrix from sklearn matrix dataset. So I'll do what? Confusion matrix, and I'll pass the actual data and, and the predicted data, and print the confusion matrix as, but let me do a new line at start as well, and do confusion matrix, and let me run it to see what it will present. I can see two mails are spam, two mails are not spam. That is why we were getting one accuracy. Now let's do this. Visualize it. Step 7, visualization. So I'm going to use a library called matplot library dot py python plot in as plt, and then we are going to import cbon as plt. Cbon is will be helpful for us to create a heat map. So first we are going to define the figure of our we are going to define the sorry we'll refer c1 as sns. So now first we are going to define the figure of our graph. It is going to be fixed size is going to be 10 is to 7. Then we will do what? Create a heat map. We'll pass confusion matrix as data for the heat map. We'll say we want annotation true, and the represent format of the annotation is going to be decimal d, and the color is going to be blues, and the x tick label is going to be the feature at x. The horizontally the features for the rows are going to be horizontally going to be uh, ham spam. Okay, ham spam. And the same for y also, we are going to have ham spam. And then we'll say the x label is going to be sorry is going to be uh, x label is going to be predicted values, and the y label is going to be y as in is going to be actual values, and the title is going to be confusion matrix, and we will simply show it. Let's run it. We can see two of our emails are correctly, they were predicted ham, and originally their value was ham. Then we have two emails, they were predicted ham spam, and then they were actually were spam. So it was, this is how the confusion matrix works here. So yes, um, I think it is looking good to me. Let me commit it so I can add the data. Commit, add code for T5 problem, push to main, and go to my repository. I can see the code added here. Thank you.